I recently bought one of these, and this is one of those USB-C testers. And this thing can tell you the voltage, the current, the watts, as well as the type of protocol that the USB device is using to charge. One bit of this has quite an interesting design to it, and I noticed this when I took it apart because, well, that's the sort of thing I like doing on this channel and in real life. So I'm going to take it apart and show you what I found. Using the wow stick for this. I've used this quite a lot actually, this wow stick. It's quite a nice little tool. So let's just take that off there. And then we'll take the bottom bit off there. And there lies our bit of interesting design. And this is quite a lumpy Schottky diode. I mean, it's probably like a 6 amp diode or something like that. And it's all on its own on this bit of board. And the other weird thing I noticed was I couldn't see any traces going to it, so it doesn't seem to go anywhere. And I thought, well, maybe it could be in the inner layers of the board or something like that, but this board's so thin it could only be a 2-layer really anyway. So I thought, well, I'll go ahead and measure that, because maybe they're taking the diode connections out to these pillars and taking them through the board like that. So we just probe one end of the diode. As you can see, it's not actually going anywhere. So what's it for? And of course, once you start looking at it logically, you realise exactly what it's for. So if you look over here, we've got the USB-C connector, and it's a little bit flapping about in the breeze. You know, there's only a couple of solder points on the underside where it's actually kind of secured on. So yeah, it's a little bit vulnerable. Let's flip this over and have a closer look. So we just turn this board over here. You can see where it's soldered on the sides there. And what this is actually for is this is a physical thing. This is to stop this connector from bending too far when it gets plugged in. So when these boards are sandwiched together, this connector is sandwiched against there, and that helps to stop the connector moving. Now I thought that was a really interesting way of doing it. I mean, you would have thought it would have been quicker to glue like a block of plastic on it or something like that, or even put maybe some metal epoxy just around here. Despite it being called metal or steel epoxy, it's not conductive, so you could easily just put some around there, which is probably what I'll end up doing with this. But no, what they did was they used a 6 amp Schottky diode. I don't know whether to be really impressed or a little bit disappointed. I mean, I suppose that's a lot quicker just to solder one of those on, and it looks like it's been soldered by hand, judging by the amount of solder there and the flux that you've got there as well. So it's been hand soldered. Certainly far easier than having to put, you know, steel epoxy around there. It's probably a lot cheaper for them to do it that way. You just sort of have to imagine the mind of the person that came up with that. It's like, how are we going to secure the board better so it doesn't bend? I know. We'll stick a bloody great big diode above it and sandwich it in between the boards. Also, as this thing isn't really intended to be taken apart, maybe they could have just put a little bit of cyanacrylate adhesive on here and then sandwich it together as well, and that would have given it a little less wiggleability, if that's such a word. I just thought it was really interesting. If you've enjoyed watching this video about alternate uses for electronic components, please like and subscribe. Thank you very much for watching. Goodbye.